So the title of the presentation is Evading Pirates and Stopping Vampires Using License Server, In-App Billing, and App Engine. Now, you might ask, okay, what do these three things have in common? License server, in-app billing, and App Engine. And they're all technologies that we're providing that allow you to take some form of your application and put it into the cloud. In this case, the way your application protects itself from pirates, as well as the way we validate that protection, is now all being put in some form or another in the cloud. But let's talk first about pirates. So piracy is a reality on all platforms, and really dedicated pirates aren't going to be stopped, which is why this talk is not titled Stopping Pirates, because we recognize that ultimately people are very people are going to be very, very dedicated to trying to the craft of hacking. But what we want to do is not necessarily target these people. Let them have fun. But let's target these guys instead. Yeah, we all know what these pirates look like. The regular pirates are, they have the eye patch and they're green and, but these guys here are the guys we really want because these guys are our potential customers. So we want to do stuff like make piracy a little inconvenient or challenging or message that it's uncool. We can use the fact that people are downloading our application as a marketing tool. It doesn't necessarily have to be something where someone comes up and they just can't play anything and they can't see anything. That doesn't help us, ultimately. We want to make sure that people recognize that there's great content out there. And of course, we want to leverage new monetization models around things like in-app purchase and ads. So how many of you were at the Android Market Talk earlier today? So one of the things that's kind of amazing is that we've now put up a list of top grossing applications on Android Market. Now, what's shocking about that is that out of the top 5 top grossing applications, 3 of them are solely funded through in-app payments, and we've only introduced in-app payments a month ago. So this is something that is working. So again, if you have something like this, when a license check fails, there's a good chance this is not going to do anything valuable for you. Okay, your customer is going to get annoyed. Even worse, if this comes up when they've legitimately purchased the app, they're going to be really upset. Although, actually, I would find that kind of cool. But there are ways in which we can approach this, again, as a marketing tool. So think about this as we go through this presentation. But let's talk first about what License Verification Library is. It is your first defense against piracy. And what's cool about it is that it is not a system that is a cookie-cutter system that every application uses in the same way. And this is intentional, because the goal is that someone should not be able to write a tool that removes this kind of protection from your app. Or if they write that tool, it's got to be really, really complicated, because it's going to have to attack all sorts of different ways you can protect yourself. And that's really the goal here. So how does this work? The application actually determines how to enforce the policy. You get to create the dialogue that comes up. You get to create the messaging around it. You get to use it, again, as a marketing tool if you want to. In fact, you can simply say, hey, man, I've got kids at home, and I make my living off of this. And you can do whatever you want. You don't have to be the bad guy or seem like the bad guy, because, of course, you're not. You're developers. And the way this works is by using public key cryptography. So we store the private key up in our server, and your application actually verifies the signed license response from our server. Let's talk about how this actually works. So once again, private key up in our server, which is actually Android Market, and public key in your application. When you want to verify the license, your application simply sends a check license request message off to the licensing service, goes to the server, it comes back down, and blam, you get a signed response. Sounds pretty cool. The nice thing about this is it has nothing to do with the platform. They can be running whatever kind of code they want. They can be running a rooted system. They can be running another, whatever they've put on there, it doesn't matter, because your application and the server are the only 2 trusted components. That was obviously done by design. But there is one problem with this, and that there is a well-known client attack. And here's what people do. They use tools to disassemble the code, and they make simple changes in the code to alter the response so that instead of returning licensed or unlicensed, it alters it. They reassemble it, they sign it with an alternate signature, and blam, protection is broken. So we realized that was going to be an issue, and back when we first released it, we suggested doing a couple of things in order to help strengthen the defenses of your application. And since then, we've come up with a couple of more ideas, and I'll share a few of those with you. So the first and most important thing is to use an obfuscator. And it's going to make it harder for someone to understand your code when it's disassembled. The second thing we want to do is to actually modify the LVL. The LVL is simply an example. And of course, there's always a problem whenever you give an example to someone, is that there is a tremendous, tremendous desire to want to use it verbatim, no matter how bad it is. And I've seen this in every aspect of my software engineering career. And the LVL is no exception. It is truly just an example of how to call this service that's within Android Market. But it is not in any way designed to be the be-all and end-all of piracy protection. So we modify it. And we also, and most importantly, we make the application tamper-resistant. We want the application to know if the user has touched it, if the user has re-signed it, if the user has done something to it that is going to change its behavior, for a lot of reasons. I mean, we want people to not be cheating in games on Android Market either. So there's a lot of reasons to make your application tamper-resistant. And the nice thing about the tamper-resistant stuff is it doesn't matter. It's not relying on LVL. It is entirely independent of what goes on in LVL. So let's talk about invocation and response handling. One of the things that the LVL does wrong is it invokes itself in onCreate, which is a logical place if you want to invoke something like this. After all, your activity is being created right then. It's very, very obvious. The problem with that is it's very obvious to anyone who's trying to hack your code that that's where you would put it. And it's always going to happen at the same time during startup. So it's very easy to trap. So it's much, much better to put it in a function, first of all, that's obfuscated, that isn't called by the framework. And secondly, doing it in a background thread, doing it at some random time makes it a lot harder to trap. Finally, again, allowing for a limited amount of gameplay is kind of cool. I mean, first of all, it becomes an immediate marketing tool. And secondly, you know, it actually gives you the ability to recover nicely. Like if the user actually has to wait for that license check at the beginning of every single game, you're inconveniencing all of your legitimate users, and that's not fun either. Definitely, this third one is super, super important, and we might even see a result of that in this session, because we're going to be demoing a couple of license check stuff, and you'll see, especially in a room like this where there's not going to be a lot of Wi-Fi issues probably, or network issues, it's very possible these checks are going to fail. And so you're going to want to make sure that what the failure you get is actually not just license failed, but it's licensed failed because the user is unlicensed, not failed because the network is down. Because there's nothing worse than trying to launch a game when you're on a plane, getting an unlicensed response, and then saying, sorry, you're going to be bored for the next 8 hours because of this. Again, we don't want to inconvenience our legitimate users as much as possible. And then finally, another thing we can do is rather than just chaining off our code and going and invoking something like a dialog, which is very, very easy to spot, invoke another activity that actually does it for us. It makes it a lot harder to track how that happened. OK, here is the core logic in the existing LVL. And there are a lot of problems with this core logic. One of them, well, I'll go through them. First of all, let's go through some updated code. So first of all, this looks a little different. Now, one is that we are not using simple values like 0 and 1 to mean licensed or not licensed. We're actually taking those values, we're performing some sort of transform on them, so it's harder to see in the assembly code what's going on. The second thing we're doing is we're actually shoving a bunch of code in between. And the reason why we're doing this is that it makes it a lot harder to see, all right, well, that's happening. Now, what are they doing with that value? You've got to actually follow it through the code. Even better if it's in ultimately a different function or it's handled somewhere else, as long as it's being stuffed somewhere. So that's a really simple thing you can do. Again, the idea, make it harder for any simple tools in order to crack your application. Tamper resistance. This is actually my favorite part. So the first thing you can do, and the easiest thing you can do, is to check to make sure your application's signature matches. Now, the signature is actually the thing that's on your certificate that is used to sign the application. So it does remain consistent between different builds of your application. And that can be done just by going to the package manager and calling get signatures, returning, in this case, the first one. Pretty simple. In this case, I am actually hashing the signature. Kind of nice. You aren't storing a big string that's obvious in the application. We're just storing an integer. So that's pretty straightforward. That way, if someone re-signs it, we can immediately tell. We also want to make sure it's not debuggable, because if it is, we probably want to do something different. It makes it harder for someone to track using the debugger. So that's easy to do too. We can CRC code files and compare. Now this sounds like it's going to be really expensive to do. I mean, you have to go through all of your code files, but it turns out that all of your files are actually already CRC'd for you because they're all inside of zip packages inside of the APK. So we can just take advantage of that. In this case, there we have it. We've now, in 4 lines of code, CRC'd all of our source files, and we've gotten the value for that. And so we can check to see if our Dalvik files have been changed. So another thing we can do if we want to go farther with this, and this is kind of nice because it uses a completely different API, is we can check to see if our whole certificate matches. So this is just using the fact that actually APK files are very similar to jar files, and you can use these same functions, which are part of our framework, in order to actually pull the certificates out. So one more thing you can do. Now, again, this is all pretty basic stuff. Another thing you might want to consider is actually adding reflection. Reflection is definitely something you can do to obfuscate your code. It can also make your code easier to hack. So we have to be careful when we use this. So let's look at our previous example, which gets the hash of the first signature. Now, we can implement this using reflection in a couple of different ways. One of the things that I'm doing here is I'm actually base 64 encoding the strings that I'm using for reflection. Again, making it harder to track what's going on in the actual source code. And the other thing that I'm doing is obviously there's going to be no linkage inside of the application that says that we're actually calling something in the package manager. And this is actually important because pretty much any of the tools that people are using to analyze APKs are watching for calls to the package manager. They recognize that people are using these things already. So this is actually a really good way of making those tools much, much harder to write, making it much, much harder for your applications to get compromised. Another thing we can do is actually add native code. So if you happen to have a native module, you can write that same thing that I showed before, looking something like this. Now, OK, admittedly, this is a lot of code. But that's because this is actually a combination of using reflection and JNI. And the first section of it actually is really the reflective part. And all we're doing is getting the IDs for all of our functions and our objects. And you really only do this once when the application starts. And the code that actually does the checking itself looks like that. So pretty straightforward. Again, it's very similar. We're just calling a couple of methods in here. Of course, obfuscating is important. We've actually added support for ProGuard into the latest version of the tools. But we realized that there was a problem in the LVL that made it very difficult to obfuscate what was going on. So anyone who's actually using an obfuscator should make this change. So what we were doing is we were actually binding to the service based upon the class that was actually inside of the LVL, which means when the obfuscator went and changed that class name, everything didn't work. And in fact, there's an elaborate workaround in the ProGuard file that comes with the current SDK. But the good news is that, in fact, you can remove that workaround and change this to something else. And again, now we've got a string there that makes it really obvious, so we should transform that string somehow. Again, use something. I don't necessarily suggest base 64. That's kind of obvious. But there are a lot of ways we can transform that string, so it's much, much harder when someone's looking for the code to figure out where we're actually doing the check. All right, another thing we can do is actually put the entire check into C and C++ code, again, taking advantage of the fact that our application is actually a zip file. So what we've done here is, OK, sorry, this is a little different. This is actually CRCing classes. This is the same example we had before. CRCing classes taking advantage of the fact that it's a zip file, once again, using JNI. But what's kind of cool is we can actually go a little farther than this. And we can actually go and use some publicly available libraries that are out there. In this case, we're using Minizip to do the exact same thing. And this line of code, when placed within the right part of the Minizip library, will actually entirely in native code allow you to check the CRC of your main classes file. And this is great because it means that they're not going to have anything in Dalvik to look for when they're trying to figure out how to hack your application. They're actually going to have to go modify the native library. It's, again, one more step that they're going to have to take. It makes it just that much harder for them to work around all of this. Finally, if you are going to call native code within your application, consider registering your native signatures from your class file with Java P-S. Using this register native methods function. And we're going to talk about this a little bit in the next session we're doing, which is on C and C++ bringing games to Android. But I thought I'd mention this here because it's very, very useful. Because by registering your methods manually rather than dynamically, it means that you can control what the names are going to be. And ultimately, that makes it just that much harder to track. Because the standard names that are given by JNI are very, very easy to see. Anyone can look at your library and see where those entry points are. This just hides them a little bit more. And of course, we can go further. I'm not going to get into these kinds of things, but we can actually store things as encrypted resources. We can use the class loader. There's all sorts of crazy stuff you can do in Dalvik, and I definitely recommend looking at it. This is kind of fun. Eventually, we do have kind of diminishing returns here. Most of the things that I have talked about here can be implemented in literally just a few hours of work. And after you've spent months working on your title, it makes a lot of sense to take those few hours of work because it does actually, believe it or not, help. And we've seen this with several applications on market that have taken these kinds of techniques and they have improved their ability to protect against piracy. But there's something even worse than pirates. And that is, well, vampires. And here's what I mean when I say vampires. Games and other titles often have server components. And sometimes Android games have asset downloads because they're really big. But if someone runs your title unauthorized, they are sucking your bandwidth. And that costs you money. So what we can do is we can actually stop vampires by making sure our servers actually understand how this whole system works. And the way we can do this is fairly straightforward. So remember I showed you that slide earlier talking about how we did client-side validation. Well, the server-side validation is pretty much the same thing. Public key is in the market licensing server, private key is in the market licensing server, and the public key is actually in our server. It's no longer even in our application. And now what happens is we check the license request, send it off to the server, and it comes back. And our application, instead of doing anything with that signed response, actually sends it up to the server. And at this point, the server is actually responsible for doing any validation. And it actually sends, in this case, a session token back to the application, which can then be used to download whatever you like. Sounds pretty cool. Once again, now it doesn't even matter if the application itself is compromised. Ultimately, what we're really doing is proxying a transaction between two servers, your server and our server. Now, there is one potential problem with this, and that is, of course, replay attacks. We want to avoid replay attacks. We want to make sure that someone can't just capture one of these sessions and use it to download the files and embed it back into the application. So the good news is that we have something called a nonce in a license validation transaction. And you've got a couple of options for how you might want to use that. You can generate it on your server, and you can store all of the nonce values. And that allows you to guarantee that each one of these license validation checks is only used once. And you're always going to have to use a fresh one in order to validate the license on an application. The other thing you can do is generate it on the client and have the server store it afterwards. A little bit harder to deal with in terms of security because you, in theory, could have collisions, but it's highly unlikely. So another thing, as I alluded to earlier, is we can change the monetization model. And a lot of this is about games, but this applies to all applications as well. So of course, considering free versions that are upgradable, using game mechanics, gamify actually the gameplay so that we can actually drive people into content. And of course, providing things that extend the game and make a premium experience. So let's talk a little bit about Android Market in-app billing. Now this is a great feature. We announced it and released it just a few months ago, and we've seen great uptake with it already. It allows you to purchase virtual goods and consumables. And again, we can do both client-side and server-side validation. So our managed items are things like your application. They're things that can only be purchased once. But the good news is that your application can actually ask the server to replay these items. And they're really designed for applications that don't necessarily have a server component. And in fact, you can even set it up so that if someone buys an item on one instance of an application, you can make it show up on another instance of the application on another device automatically. But you don't have to do that. Unmanaged items are SKUs in market like your application, but they can be purchased multiple times, and your application cannot ask for a replay. So these are harder to secure. Having your own server is really, really useful in all of these cases, but especially in the case of unmanaged items. So how does this look? Well, at a high level, it actually looks almost exactly the same as what we did with the license validation library. We have the private key sitting in the market server and the public key in our application. And we send a request off. It signs it with that key. It comes back, bam, into our billing receiver. The server version is almost identical. Once again, at a high level, this is what it looks like. Pretty straightforward. Now, one thing I'm doing here, and I thought I'd point this out, is I'm adding credentials. And this might be useful if what we're trying to do is actually support account information across multiple devices. Ultimately, what's going to happen is that this transaction is going to end up getting an ID that's generated by the server. But in order to avoid any possibility of replay attacks, adding a credential is actually useful. And once again, now that we have our server-side version, we can do the same thing. We can deliver new content as the result of an in-app billing transaction. But let's go a little bit deeper here, because in-app billing is slightly more complicated to use than license validation, for obvious reasons. So here is our application activity, and here is Android Market. And the way this works is we start off by requesting a purchase. Now, before you do this, you should make sure that you actually are on a version of Android Market that supports in-app billing, and there's a call to do that. I'm not going to go through that. Then it ends up bundling a response code that includes a purchase intent. And we are then going to execute. We're going to invoke that with a start intent sender if we're on Android 2 or above. And that causes the checkout UI to get displayed on top of our application, and actually comes up as a non-full screen activity, which means that our application then goes into on pause state. Now, for those of you who are writing games, if you at this point go and dump all of your textures, or you're using the standard GL Surface View that dumps all of your textures, you're going to find out that it's going to take a couple seconds potentially for this to come back when you reload everything. So you might want to take a look at this case and optimize around it. So in fact, we don't necessarily dump until on stop. Then the user is going to actually say they buy something, and we get an activity on resume followed by a broadcast result code saying what happened. So then we of course say, well, what did they buy? We get the information, and it comes back into broadcast. Now, the key thing about these operations is that the first section here, the request, purchase, and that bundle, are synchronous. After that, these are entirely asynchronous operations. So it means that you have to think about it when you're writing your application. You have to make sure that there's something that the user knows, that there's something still going on in the background. It may take a while. We have fraud prevention and all sorts of stuff on the back end that we try to do to make sure that the system is working to its best, but that can take some time. So there is a delay that will happen here. Finally, at the end of this, we get a purchase state change that lets us know that the purchase actually went through or didn't go through. And then we say to the server, yes, I got that message, which is important, because if we don't actually confirm the notification, the server is going to try to keep delivering that notification to us again and again and again until we confirm it, which is very, very useful, because your application could get killed in the middle of this, and you want to make sure that when your application is up and running, it actually gets the notification, confirms it, so you actually purchase the item, give the user what they bought. And then finally, it lets you know that it received your confirmation. So that's how you do it without a server component. In order to add a server component to this, it's pretty straightforward. We're going to use the technique in which the server actually generates the nonce. So we're going to start off with sending a request to our server to get that nonce and getting that nonce back. And then, when we actually go to confirm the notification, what we're actually going to do is perform the server billing side authentication on our server, send it the credentials that it's gotten back from market, and then finally return that we've validated the billing response. Now, in our particular example, all that we've done is actually taken a session ID that we generated earlier and validated it. And Trevor is going to be demonstrating that in just a moment. So Trevor, if you'd come up, actually.
OK. So if we can switch over to
Yes.
the projector here, which I think is number 3.
Sounds good.
There we go. All right. So this is a small little demo app that me and Dan have been working on to go and demonstrate all this. We'll be releasing the code sometime after Google I/O is over for all of you to download and take a look at. But basically, it just goes through exactly what we just talked about. So I have my nice little downloader app here. You can tell that the UI is very, very awesome, right? And we implemented both techniques you can use here, either checking a licensed server certificate or through NAT billing. So we're going to show you NAT billing here. And so when I push that, 2 things are happening behind the scenes here, assuming Wi-Fi works. First off, we're going to go and get that nonce. And then we go, and as soon as we get that, we make our in-app billing request. So let's go ahead and buy this with my nice fake credit card here. All right, that comes back. You see a slight delay there where we wait for Market to go and confirm everything for us. And then we get a download content button. And so when we push download content here, 2 more things are going to happen. First, we're going to go and take all of the signed data the Market sent us and send it back to the server. The server's going to go and upgrade our session token. And then we're going to go and start downloading our files. If Wi-Fi works. So, and there you go. So I could go into the Market Publisher console and go and set it so that instead of a license response or a purchase response, we can go and set it to send us a, excuse me, since this is NAT billing, I can go and change the test queue and say that that the purchase didn't go through. But I'm not going to do that because, quite frankly, it's not that interesting. Nothing happens. Everything stops, which is exactly what you want, right? And so when this finishes downloading, which probably will take another minute here, so I'm not going to bore you all, we get a nice little video file. You can click play, and you'll get a nice map of all the Android activations. So.
So this is an example, yeah, which I should probably continue on. So this is, we're not going to switch to the slides. I do want to actually show that. But what's kind of cool about this is actually a sample that we wrote that takes the original source code that was given in both the license validation library and the in-app billing library and actually ports it to standard Java SE, and it's running under App Engine.
Correct.
And let's see, and we're actually playing.
Yay.
One of my favorite videos.
So yeah, like Dan said, the important thing to note here is this is the same source code you have as part of the Android SDK. And since it's Java code and App Engine also supports Java, we can pretty easily just go and copy that over. And it actually doesn't take too much work to get it working. So
that's right. Even Trevor and I could do it, which means all of you can do it.
Yeah. All right. Let's go back to the slides. Maybe.
All right.
There we go.
There we are. OK, so let's talk just a little bit about App Engine. And App Engine has been really good to us because we needed a place where we could host that Java code and do that validation, and also, in this case, host the binary that we're actually downloading. So, of course, it allows you to run your Java code on our infrastructure. In this case, we're using it to validate license responses, secure transactions, and serve files directly from the blob store. And what we're actually doing is there's actually 3 different programs at action here. There's actually an App Engine application, which is handling almost everything. There's actually a small Python script that we wrote that actually does bulk uploading into App Engine and stores things in the blob store. And then, of course, there's the Android side module, which we just demonstrated. And again, this is useful as an example. But remember, this is just standard code. It can be run on any Java-capable server. So how do we create an App Engine project? So we're going to go through this very, very quickly, but it is very, very easy, especially if you like using Eclipse or if you just have Eclipse. You can just install the plugin. You can then literally go through this wizard, which will create the App Engine project for you, and it creates a little servlet that you can fill in. And then you can literally launch that servlet by going and clicking Deploy to App Engine. It really is pretty much that simple. And we give you a bunch of tools to manage it as well. You can look at bandwidth. You can see who's connecting to it. It's kind of cool. You can also get log information. But let's look at what the code actually was like on App Engine. So now, admittedly, I'm not going to show the entire ported code because it would take a long time. It would bore you even more. So what I am going to do is show you the module that actually handles the request for data and does the validation. So all this is doing here is actually going to generate a session. And what we're doing here is we're actually getting the signature from the device. And we're passing it through that same license validator class that is part of the LVL. We're calling verify just like we would do on the device, and then we're returning that value as part of a new session token, which is now validated. Now again, this is just an example of how one can build this kind of server, but it's pretty straightforward. There's a very small amount of code that needs to be actually written. So while I have you all here, let me talk a little bit about cloud services in general. So your application actually can take advantage of cloud-to-device messaging, which is, of course, basically what we're using the background for Google Talk and for Gmail to send messages. Also, the backup service. And then, of course, in that other pile, we have Android Market, licensing, and billing, which I've talked about here. So cloud-to-device messaging, we announced it last year at Google I/O. Pretty cool. It launches your app if it's not running. It leverages our network connection, and it queues and delivers messages. And it's pretty straightforward to set up, and I'll go through a real basic flow here. And the reason why I'm bringing these things in as part of this application is these are all part of a bunch of cloud services you can take advantage of in your application. And I think it's important, especially now that we're seeing such an enormous percentage of devices that are running Froyo, that people, for example, start to take advantage of C2DM. We're at over 65% of devices now that are running Froyo. So basically, we start with the registration flow. It's pretty simple. Your application needs to register itself with the server, and your application has to forward that ID across. Then, on the back-end side, your server actually has to create and store a session with cloud-to-device messaging, and finally, return the response. After that point, you can send messages to the service, and it's going to send intents to your application. Pretty straightforward. Application data backup is kind of interesting as well. One of the things that I found is really frustrating is that I move around between Android devices a lot. I don't know how many of you do that, but I find I do it more than most, probably. And it's really frustrating if I'm playing a title or playing a game, or if I even have settings and they don't end up getting transferred automatically between devices. And of course, we provide that capability with application data backup, and I want more applications to use it. It also can be used for a couple of cool ideas. Like if you want to be able to track things going across devices, you can actually have that same session carried across devices with application data backup. And this flow is pretty straightforward as well. You basically tell the backup manager when you have data that has changed. It then gives you an on-backup request, and it backs things up to the cloud. Now, obviously, if you look at this, is actually part of the framework. This is actually not tied to Android Market, so you're relying on whatever cloud backup infrastructure is on the device. Restoring is pretty much straightforward as well. If the application is installed, if data is backed up, it will send you an on-restore. So it's pretty straightforward, and it allows you to do a lot of things, and it can also help you track what's going on with usage across users. So one more thing, if you like the Androids in this presentation, please consider Androidifying yourself. It's really fun, and it saved me a lot of time making artwork. So now we're going to open the floor for questions. Now, please use the microphones so that people outside of this room can hear you, or maybe even so that people inside of this room can hear. And Trevor and I can both take your questions. Thank you.
So if you're doing something like you mentioned, you're downloading this large movie, you don't want them to be able to download the movie and then just send it to all their friends. Are you doing that by virtue of putting that in the application store?
Well, if you've got a couple of options here. I mean, I think in this particular case, we want to stop them from using bandwidth on our server. Our goal was not to actually try to protect the content. That's a secondary thing. Now, of course, you can take that content, whatever it is, you can encrypt it however you like, you can get a lot of per-device data there, and you can do that on your back end. But that's kind of a secondary problem versus the problem of just trying to prevent someone from leeching off your bandwidth, which is what we were, in this case, particularly talking about.
Okay, and if you don't have your own server, the Android market doesn't have any mechanism for storing binaries. You need to kind of create your own server for
Well,
that.
as far as what's tied to in-app billing, that's correct. At the moment, we do not have anything like that. And but again, we do have things like App Engine. App Engine has a certain amount of free quota, and so there are ways in which, depending on how much data you have to store, you can still find facilities out there on the web, whether it's through us or through someone else.
Okay, thank you.
Sure.
Yes, my name's John Coriat. I have a free app called Radar Now. I have like about 1 million active users, and implementing like license checks and stuff like that, I'm not sure if that's good for a free app. I'd like to implement in-app billing, but that's adding another layer. What's your feeling on that?
Well, so license, I should have made this clear at the start. So license validation is something that only applies to a paid application.
Okay.
And as far as in-app billing is concerned, I think that if it fits the business model, I think it can make sense. Obviously, you have to have something that drives someone to it. If you do use in-app billing and you're doing an app that's not server-driven, I definitely recommend using a lot of these same checks we're talking about in terms of integrity, because again, that now becomes a surface area for someone to attack. So, but for a free application, it's typically not something that's required.
Yes, so what I have in mind is adding features that have been requested over the last 2 years by users begging for new stuff, and the in-app billing thing seems perfect. I want to implement it in a subscription role on my own server. That's no issue, right?
So I mean, the only issue with in-app billing and subscriptions is there's currently no support for subscriptions in our in-app billing directly, but you can use it as an unmanaged item, and you can manage those transactions yourself. So you can just notify the user that their subscription's running out, they have to do another purchase.
Very good. Thanks very much.
Sure.
I would like to ask a question. Once you have pirated apps out there, then you can implement the LVL and stuff, but other than coming out with new updates with great features, is there anything else that you can do with things that are out there in the wild?
If you don't have a server component, it's tough. I mean, obviously, my general feeling is that it's useful for every application to have some kind of server component if possible, even if that's just for analytics. I think it's important for applications for developers to know who's using their applications, where they are, what kind of install rate they're getting, even beyond what they get from market, which is pretty good. But that would be, so my feeling is, yeah, it's hard. I mean, once it's truly out there, there's not a lot you can do. So.
Hi, my name is Bo Stone. I do Droidian for LinkedIn. It's the first ever LinkedIn app. And here's the question. I have a pro version of the app, and all it really does is removes the ad, Google ad, from the application. So I would like, going forward, to make it available as basically in-market purchase, in-app purchase. But what's really stopping me is that what do I do with all my happy customers that I already have? So if I remove that code that I already have for verifying the license, what they're going to do with my future releases? And so if you don't have that, I mean, I treat it as a request. I just need a mechanism of taking the existing license and maybe giving my customers a voucher that they can basically then go into a market site and purchase, basically use it to convert that license into in-app license.
Right. I mean, I think so. I mean, so the only way to do that right now with the system is for it to be an unmanaged transaction, for you to store that kind of information on your server. Then, because that gives you all the flexibility to control how you use it. So if you put up a little server and you have it and you tack on there, it's still not a perfect solution, and I'd like to support that, honestly. But right now the only way you can do that is through an unmanaged transaction.
All right, thank you.
Sure.
Yes, hello. In terms of this was mainly for let's say paid apps or in-app transaction. But for instance, if if I want to just save some information and want to obfuscate it, let's say like an API token,
Right.
and sometimes a secret as well, is there any best practice? I mean, would you recommend a way to ensure we can obfuscate some data that it's either specific to a user, like some kind of hash of his password or something of that sort, or a token in a way that makes it difficult to just retrieve easily? And where would you place it?
Well, I mean, ultimately, I guess there's kind of two things. If you're trying to protect the user's data from other applications, the platform does a pretty good job of doing that already. As long as you store data in private locations, and that's one of the places in which the platform really tries to secure data. And of course, obfuscating things on top of that is good, because of course the platform could be compromised. There's no such thing as a perfect system, but in general, the platform tries very, very hard to make sure that there is a sandbox that applications can't get out of to make that happen. As far as best practices in general for obfuscating, I mean, I think that some of the things we talked about here are not exactly relevant to actually obfuscating data, but if you look inside of the LVL, there's actually an obfuscated preferences module that we actually give you as source code, and that's probably a good place to start. And it includes a pretty straightforward implementation of that, and you can certainly grab that code and use it. It's part of the freely available library.
Okay, and just as a continuation, would you always execute some kind of, I suppose you have to, but obfuscation and all this kind of processing power just every time you need to access it? Let's say, for instance, if you have like a is logged in method where you want to know if the user is logged in, you each time has to execute, let's say, this entire process of running another thread and,
I think that it really depends on whether it's going to adversely affect the performance of your app. If it's not, then I see no reason why not to execute it all the time. If it does, then obviously you're going to want to make a compromise between some level of security and some level of performance. I think it really is on an app-by-app basis.
Okay, thank you.
Hi.
Oh, yeah.
My question is on the free apps. Free apps you cannot do really the license validation check, right? But I still want to do the vampire attack. Some unknown people are taking my free app and start using my server-side resources. So how do I go about protecting that kind of free apps, but at the same time vampire attacks?
It's an interesting problem. I mean, I guess the question is, in general, with the free app, the goal is to have as many users as possible. So are people misusing your app in some way, or is it,
Yeah, for example, take the code and decompile and modify certain things and make it work on some other device which we really don't want to work on certain device.
I see. Yeah, I mean, in that case, LVL isn't going to really help you because, ultimately the thing to do is focus on integrity checks and try to make sure that the code is as functionless as possible in those cases, and make sure that if someone's touched your code, a lot of those things will really make it very challenging for them to get your application to work, and hopefully they'll give up. But if they don't, that's at least hopefully you've created a window of opportunity for your application. Now, if you're talking about using server-side resources, a lot of the things you can do are actually take things like encrypt pieces. One of the things that's very successful actually is taking pieces of your code that are well known and using them as keys that you send up to your up to your server. So do things like grab the CRC of this, and don't necessarily use it for an integrity check, but actually use it as a key that the server ends up using to send content. So that's another method. You can actually directly incorporate integrity checks into helping to prevent misuse of your application.
Right. Yeah. And it's also worth noting, I mean, what you're trying to do ultimately, when you're trying to do an application integrity check, is make sure nobody's tampered with the system. And to do that, you really need something like a DPM, which unfortunately Android doesn't have support for. Who knows, at some point in the future we may or may not get that, but really that's the missing piece for what you're trying to do there.
Yeah, but the key thing I think is, again, you can take advantage of values that come from integrity checks, things like the CRC, things like your application signature, things that are very difficult to tamper with, and use those and send them directly to your application and use those to actually validate what's going on. Now again, all this stuff can be spoofed. It's not a perfect system, but you can make it pretty challenging for someone to figure out what's going on.
Continuation on that, when you said that application can proxy the encrypted data coming from the Android Market and then send it to our server in the back end. But what server has to do at that point? How do they validate the response?
So ultimately, it's what I was talking about before. The Android Market signs everything with a private key. And so then what you do is you put the public key that's associated with that private key, and we give that to you on Android Market. You put that on your server, and you actually use that to validate the signature that comes back in from Android Market. So that's how it creates a relatively secure channel between the market and your application, even though the market server isn't directly talking to your server.
All right, thank you.
Yeah, take a look in the in-app billing source code. There's a security.java file that shows you exactly how to validate that response. And the source code we'll be releasing will show you how to do that.
Yeah, exactly.
In the sample project that you created, did you actually take the time to decompile your own application and try to hack it? And in that case, which methods did you find were easier to circumvent than others?
So, well, this one in particular, yes, we do. So to answer the first part of your question, yes.
Okay.
But in this case, since we're doing server-side validation, there's actually no attack window on the device. Because really, what you're doing is validating a signed piece of data that's coming from the market server. So assuming that you can't tamper with the market server code, which hopefully you can't, and assuming nobody can tamper with your server, all the actual validation is being done on those ends, and the device itself is just acting as a conduit for the two to talk to each other.
Yeah,
Right, so that applies to your in-app purchasing example.
And
But
the
what-
LVL example as well. What's more interesting is when you get into the anti-tampering examples, and so there actually are tools out there that you can actually run, and there are some websites that have created some fairly sophisticated tools that try to break this kind of protection. So that'd be my first effort on that. And yeah, I actually designed some of these examples based upon the results of that tool. Now, of course, the tool is going to get updated, so don't use my examples verbatim. But definitely, that's a good place to start. I mean, the last thing you want is for you to put a lot of work into something and to have it immediately get compromised.
Right. I also have a follow-up question. What are your thoughts on third-party libraries such as Urban Airship and the services they provide versus how basically it's essentially copy and paste for every application? Are you familiar?
I'm not. I don't have enough familiarity with what they're doing.
Basically, they handle the server-side validation, and you drop it into your application, and they provide the transport mechanism for the content to your device.
I've seen some things like that. Yeah, I don't really have an opinion on them. If they work, that's great. It's not. Again, we're just trying to show you how to use the APIs to do it. But if
Right.
they're doing it for you, that's awesome.
And what is the best way to use in-app payments for opening some extra premium features of your application? Because in this case, you should have all this code also inside application, and attacker can use all these techniques to get it, to open it.
So my general best practice on that is to try to have resources that are not in your application that have to be pulled in from a server. And and even better, if they can be encrypted with some device-specific information, that makes it a lot harder for someone to break it and use it, especially if that decryption is being done like inside of native code, or if it's being, for a lot of game titles, that's actually very, very easy. That's how they're already accessing those assets. So that would be one way if you want to actually put a little bit more, to make it a little bit harder, a little bit more obfuscated. So I like that method. There are plenty of other methods too. I mean, if you look at the latest versions of Unity, they actually do a bunch of things to try to help people out in this exact same way, in order to help them encrypt resources and unlock things in the application. But I think a best practice is to actually download something else additional to the application.
And even DEX files to the memory?
The problem with DEX files are interesting. The problem with DEX files is that you can't actually encrypt them because they have to be loaded in the internal file system. You can't actually load them from memory with our class loader. So yes, that's not a bad idea if it's a small class that does something integral, but it doesn't necessarily provide you that much protection, and it is a lot of work to set up. And it also is something that is in general, downloading code is sort of a questionable practice, even though even though the actual system will prevent it from getting to any resources that your application hasn't already asked for. It does mean that your app is ultimately responsible for a potential additional vector for compromising the system. So as a general rule, yes, It's one way of doing things, but it does mean that your application could potentially be used by something else that's naughty if it can figure out how you're dealing with that text file.
Okay, thanks.
So,
Hi, Dan. Why not close the loop and have the market server communicate with your server?
it's something that I think would be an excellent addition to the API. I don't think cryptographically it's required, but I think that it would make life a little bit easier for some applications, and it's something that certainly we've talked to the market team about.
Yeah, so just to follow up on that, and to be clear, from a security perspective, the way we're doing it versus providing an additional API on the market server that your app could talk to, they're essentially equivalent. The downside is having an additional API actually adds one more round trip worth of latency to your check. But again, there are some specific cases where it might make life easier on developers. So we definitely have a feature request open for that.
All right, thanks.
All right. Well, if that's it for the questions, the next session here is going to be on bringing your games to Android with C and C++, and myself and Ian Lewis are going to present that. And let us know how we're doing. I had a speaker meter URL up there, and so please do check in. We do actually listen to your feedback, and if you thought this was a giant waste of time, let us know. And if you thought it was interesting, let us know. And we'll be back next with bringing games to Android in C and C++. Thank you.